So I also want to talk a little bit about the new very advanced design, which is a PCI Express Protocol Analyzer. This is one of the early prototypes. I have about 20 of these manufactured and ready for sale. The way this works is, as you can see, first of all, it uses the same form factor as the older USB analyzer. So you have the FPGA here, you have the same USB controller, same connector. Everything related to FX2 processor is the same, but the FPGA is much more powerful, mostly because of the higher speed of the data that comes in. This one is running at 2.5 gigabit per second, and there are 4 lanes upstream and 4 lanes downstream. So there are several gigabytes, not gigabits, several gigabytes of data per second that come in here and needs to be stored in this 2 gigabyte SDRAM. So, for example, to explain how much data that actually is that this captures, the 2 gigabyte worth of storage in this SODIMM up here gets filled up in about 800 milliseconds for all those lanes. The connector on the front here connects to an external probe using this Molex cable. It's a very expensive cable. It costs about $100 just for this cable. And then you connect the other end into the probe like this. And then, of course, let me turn this around so you can see. The idea then is to plug this probe into your motherboard using the lower connector here. Goes into the motherboard slot connector, and then you connect your device on the test. This is a host bus adapter for a SATA and SAS. So you connect this in here, and then whenever the device under test, the host bus adapter communicates with your motherboard down here. These little splitters here, so you have 4 for the upstream data, on the bottom you have 4 for the downstream data, will actually send a copy of the data off to the protocol analyzer through the cable. It also sends a copy of the 100 MHz PCI Express reference clock up to the USB analyzer up here too, so that you can correctly follow the speed of the bus, because otherwise it's not certain that the clock speed is exactly the same on the sending and receiving sides. So let me go through this design a little bit. One of the things that made this design a lot more advanced than the other 1480A design, again, this is USB analyzer, this is PCI Express. USB 2 is quite low speed, 480 megabit per second, and PCI Express Gen 1 runs at 2.5 gigabit per second. And also this one only has 1 lane, goes 2 ways. This one has in total 8 lanes of data, each running at 2.5 gigabytes per second, because you have 4 lanes up and 4 lanes down. So the main thing that makes this complex and more costly design than the older 1480A USB analyzer is that you have a very large SODIMM on this one, which requires a lot of power. So you have here a switched power regulator to generate the 1.8 volts and about 3 amps of power, or current I should say, when it's running. And this has a DDR2 SDRAM interface as well. Because of that, you need a more powerful FPGA. This one is a Arria 2GX FPGA from Altera. And of course, the older 1480A USB analyzer design also uses an Altera FPGA. you have a second switch regulator which has a produces the 0.9 volt power rail for the FPGA core in here. Underneath you have actually linear regulators for the other 3 power rails required by the FPGA. To squeeze everything in this small board size, I had to make this board a 10-layer board. So you have 4 signal layers and the rest are power planes and ground planes inside, which also makes it more expensive to design and manufacture. At the rear here, as you can see, the bottom one is the 1480A USB Protocol Analyzer, and you see here on the PCI Express one there's a trigger port which allows you to connect this to a external measurement instruments. So let me see what that looks like if I get a PCI Express Protocol Analyzer, which is actually in the box. It will look like this. So in order to make the instrument a little bit more sleek, I didn't want to put the BNC connector on here, so I'm using this adapter instead that you plug in, and then you have the BNC connector here that you connect to your coax 50 ohm, and you plug it into your logic analyzer or scope or whatever you want to hook up. And this rear trigger port can be set up to trigger as an output. So whenever the hardware trigger inside the PCI Express Analyzer triggers, this one asserts either high or low, depending on how the software is set up. You can also use it as a trigger in. So whenever something external happens, then it will trigger again going high or going low. It could trigger the 2500A PCI Express Protocol Analyzer. So I also want to show you the software for the advanced 2500A PCI Express Protocol Analyzer, and that is running here. There are a lot of features in this software that will be part of the new 1480B USB analyzer design, so therefore I want to show you the features in this software, since they are essentially the same and will be ported over to the 1480B. So I have here a already saved capture that I've taken previously from a target system. So we can just open that trace and take a look and see how the user interface works and what features are available and how they are improved compared to the older 1480A USB Protocol Analyzer, which I showed you the software of before. So it's filtering the protocol view. Essentially it's building the protocol view from the 2 GB worth of data, and that only took a couple of seconds. And here we can see that immediately here you see a similar view to the USB Protocol Analyzer, in that transactions and packets, or rather I should say the packets are displayed within higher level transactions. So that means that, for instance, if there are a lot of packets going back and forth, they're all being neatly organized under the transaction that the packets belong to. And here you can see the scroll features, and this is part of the dynamic data access that this protocol view does. It has actually, the software has created an index of all the protocol items in the whole trace, the whole gigabyte, the 2 GB worth of trace memory. And because of that, you can immediately go from the beginning and scroll to the end like this, without any delay whatsoever. You don't have to wait for any decoding. The data is right there to be viewed. So just like in the 1480A USB analyzer, you have a details view which shows in either text form or decoded packet form exactly what data you are looking at. A new feature available in this software that will be available in the new USB analyzer software is that you can now go in and select here a number of fields in a packet, and the corresponding location of that in the raw data will be displayed in the lane view. So here you can see that this packet, you can actually do a select all even. You can see that this packet is a device to host packet, which is also shown in the protocol view. Here you can see that there's a left pointing arrow. That the left pointing arrows are the packets going towards the host. So you can imagine that the host is up here on the left side and the devices are to the right. So this goes from the device to the host, and this from the host to the device. So that is a new feature that will be part of the 1480B advanced USB Protocol Analyzer. You can also see that you have the same kind of payload view as in the USB analyzer, but you can also copy to clipboard. You can select copy to clipboard, and then you can paste it in some other application like Notepad, and everything will be copied over. The copy to clipboard also works for in the protocol view. You can just mark up the beginning and the end and right click and copy to clipboard, and then paste it in wherever you want. So all these fields then you see up here will be copied to a clipboard. You can also do data export via XML, and to do that, if you try to export right here, you will get a warning saying that you have to assign two markers in the protocol view, and that will be the beginning and end markers which define then what data to export. So you can just add a marker, and you can say export start, and then you add a marker down here that says export end. And as you can see, you can also choose the color now in the more advanced software. So we set it there. So now we want to since we have the markers defined, you can either export the data between this marker, or you can actually print the data between this marker. So if we first do the export, you select the export protocol view items, and then you say that you want to export between export start and export end, and then you click export to XML and you put it on disk. Oh, you have to say a file name here too. Exported, and you save that, and it's done. And then when you open that file, then you will see all the data in XML format, so you can actually get all the information that's available here, including all the details information available in all the details view and so forth. So the exported XML data contains all the data available in the trace between these two markers, so you will not lose any information by doing an export. And that means that you can grab the data and process it in your own application afterwards without losing any part of the data. Since we have markers defined, we can also then do a print on it. So what you can do then, you select your printer and you select the markers which define the beginning and end of the data to be printed, and you can actually do a print preview here. And this is very fast. The 1480A has a very simple print engine. This one is vastly improved, so you can print very quickly, and you can actually also drag this window around. See if I can resize it here. I can make it smaller. See, zoom 150. But as you can drag it around and look at the details, you can move to the next and previous page and so forth. And when you're ready, you can just print it. And of course, you have the regular page setup and so forth. So this is a much more advanced print engine than the previous one in the 1480A USB Protocol Analyzer. So the plan then is to move this over to the 1480B, so you get that functionality in the USB Protocol Analyzer too. If we then look closer in these pop-up menus that occur, you can see that you can hide and show protocol analyzers. So if you go, actually previously when I saved this trace, I have hidden a number of packets in the trace that are not interesting to view. And here you can see the checkboxes here are actually, some packets are hidden. You can go in and say which ones. In particular, the update flow control, the FCP and FCNP, posted and non-posted, have been hidden. So you can actually unhide, and those will show up here. Or you can just hide them again, and they will be gone. So this is something that's vastly improved from the 1480A, and this feature of individually hiding and showing packets, and as you can see, it's very fast to show and hide packets, because all the packets in the whole 2 GB trace RAM have already been detected, so the software is aware of their location within the trace. So this is immediate, the filtering functionality. So what you can do is you can show all items again, and you can see that this is the beginning of 2 GB, this is the end. You can scroll through it all without any delay whatsoever. So then if you want to only see the data transfers again, you can go in here and you can hide the DLLPs. You can hide this DLLP too. You can right click, go hide, skip ordered sets, hide those. You can hide the ones that go the other direction, and then you can get rid of these two. And you have a couple more, there are different versions of them. And here again you have the resulting trace. So it's very easy and very fast to show and hide protocol analyzer, protocol items in the trace. So this feature of hiding individual tree nodes or protocol items via the node finder is something that is planned to be integrated into the more advanced USB 2 1480B Protocol Analyzer 2. You have the copy to clipboard again. You have the select all. Of course, the trace is very big. There are about 26,154 rows here, so you probably don't want to do that. You could if you wanted to, but as you can see, it takes some time. So selecting and copying the clipboard is recommended only to do for fairly few protocol analyzer items. If you want to export a larger range, then you should define markers in the protocol view like these. The start, let's see, these two, the start and the end, and then export using the export to XML functionality. That is a lot faster. You have edit, delete, and delete all markets. You have a search payload. And as you can see here, it looks quite similar as the 1480A search payload data dialog. One addition here is you can search either link direction or both. And also the searches here are actually done on a background thread. So if you search for something that you know is not there in the trace, the search would then be kicked off, like you see here, on the background thread, and you can continue working, analyzing your trace while this is going on in the background. Markers view, I already showed you that. Whenever you click on a marker, the protocol view will change to that location. You can also here do a set the time reference, and then of course it would change up in the protocol view, in the markers view, as well as in the lane view down here. I should say that the lane view is showing the data exactly as it happens, or as it was transferred on the link and the test. So see if we can get one of those skip ordered sets here. There was something there. Nope, this is a actually it's a packet in that location. Get another one. Yeah, maybe that was a skip ordered set. Yes. So here you can see all the way to the lowest level. For instance, here there is a skip ordered set that goes from device to host, and of course it sends the skip characters on all 4 lanes in parallel. We talked about searching, the printing and exporting, and set and clear time reference. That's about the same as in the 1480A USB Protocol Analyzer, so I'm not going to talk too much about that. The context menu also appears here, but of course if you do something in this view, you will actually export data. For instance, if you try to export lane view items, then you export from the lane view instead of the protocol view. So you can actually export the raw data to XML2, or you can export the protocol view data to XML. And of course you can select and copy to clipboard as well, or print it. Another thing here in the PCI Express Analyzer 2500A is that you can select the trigger position within the capture buffer. So here you see that the capture buffer size is 2 gigabytes. That can be changed to something a lot smaller in case you want to save smaller data files, you know exactly what you're looking for. And you can set up the trigger to trigger on that. You can set the trigger point then to be at the beginning or at the end of the buffer. So for instance, if you want to trigger 50% of the trace, or you want to capture 50% of the trace that are before the trigger point and the rest after the trigger point, you just set this slider in the middle. So if you want the trigger position in the beginning, you set it somewhere here. Link width should match whatever your link width is on the bus under test, and as you can see below, the sample trace here used a 4-lane link, and you can individually invert the polarity on any of these links, or lanes I should say, in case it's inverted on the physical lanes. And the lane mapping then could be standard or reversed, so or even custom. You can drag and drop like this, put it over here or put it back, so it's quite flexible. So that's the capture configuration. You also have a trigger configuration up here, And this is very advanced 8-level sequence detector. The Arria 2 GX FPGA in the 2500A PCI Express Protocol Analyzer has quite a lot of onboard RAM, which allows us to define very deep sequence detectors. So let's go and copy this to a custom sequence, and then you can see that you can, for instance, this one that was predefined would trigger whenever an STP control character is detected on lane 0, and that would be then any STP packet. Or any TLP, I should say. There are two kinds of packets, TLP packets and DLLPs. So this is the TLP, and you have a token called SDP, and that's the start of data link layer packet, and this stands for start of transaction layer packet. As you can see here, you can define up to 2048 custom characters, so you can pretty much trigger on anything. And you can also define the sequence. You say, for instance, that 250 or up to 2K should look like this, but only in the host to device direction, and then you can define the next level to use sequence detector 1, and you go in here and you do the same thing. You define whatever should be detected for that level, and you have 8 sequence detectors, 0 to 7, which means that it's quite flexible what you can trigger on. And you also have a trigger port configuration, and that is, of course, determines the rear trigger port here, what should happen in regards to that. So you can either trigger in or trigger out whenever the trigger sequence is. So if you trigger in, then that will trigger the capture, and you would stop the software at that particular time. If you trigger the out, then the sequence detector here will trigger the analyzer, and it will assert either high or low on the trigger output. And you start and stop the capture up here, of course. Updates, go to our software. Consulting, we offer consulting services for anything related to peripheral device and device driver consulting. And that's through my sister company, Summit Soft Consulting. So we offer Windows device driver, board design, printed circuit design, circuit board design, SI/PI integrity analysis, and so on and so forth. And then, of course, you have the About box right here. So as you can see, there are a lot of features that have been added in this software, not available in the 1480A USB analyzer. Most notably, it's the trigger sequencer. The 1480A does not have a built-in trigger sequencer, so you capture the data and you have to analyze it and look for what you're looking for afterwards. So that's one major feature that will be part of the 1480B. Another one is the printing is vastly improved, and you have the XML exports, which is the third-party interaction with your own application. You can parse and process the data after it has been captured. The 1480A did not have export functionality built in. And of course, you have the drag and drop functionality of the views, which is sometimes very useful. Sometimes you want to view, for instance, payload and the lane view at the same time, then you can drag it over here. You cannot do that in the 1480 A, because both of those views were stuck on the same tab down here. So now it's more flexible to move things around. And again, the hardware protocol item acceleration, which is the feature where the hardware actually detects and generates the location and information about all the protocol items in the trace. That's what allows the search and sorting and hiding to be instantaneous like this. And you need already hardware indexed locations of all the protocol item locations to be able to do search this fast. Notice that this is a full 2 GB trace that is on the fly being filtered like this. And you can then again go to the beginning, go to the end. You have all the data right at your fingertips. And you can also do it from here, of course. You can hide and show. So if you only wanted to show the HD TLPs, then you would uncheck this. Here you can show all the packets again, show all those packets. You can hide anything related to device to host direction, goes towards the PC. Then this is what's left in the trace. So it's very, very flexible, very fast, and has been optimized to work together with the hardware for a maximum speed and flexibility. And most of these features will be ported over to the 1480B USB Protocol Analyzer. That pretty much sums it up. Thank you very much. So if you're wondering how much work goes into creating something like a high-end PCI Express Protocol Analyzer with features that I described, then you would pretty much have to look in these 8 folders. These are the research notes that pretty much cover everything that I've done over the last, well, more than 4 years now. So I started in February of 2010, and this is essentially all the research notes that go in. So everything from basic hyperlinks, signal integrity research, probe, define DDR2 design. Here we have SODIMM research. You have FPGA research, which one to use. I originally wanted to use the Arria GX design, but unfortunately that didn't work with a DDR2 SODIMM because there wasn't enough DK groups on that chip. So I had to upgrade to an Arria 2 GX instead. So you have that, you have a prototype board manufactured. Here you can see the X-ray of that. That was in 2011, April, end of April. DDR2 board bring up was done back in June 2011, and so on. And see, I can get this back up there. So that's pretty much a lot of work that goes into buying one of these, or creating it rather. For the USB analyzer, which I showed you, this is the circuit board then for the 2 products. So the first one here is the USB Protocol Analyzer, and the second one is the PCI Express one. So obviously this is USB 4 binders, this is PCI Express 8 binders. So you can see that the PCI Express one is a lot more complex than the USB one, mostly because the more advanced and faster memory interface, but also because of squeezing everything in to a small PCB size like this one, which required then a 10-layer PCB.